everybody, and welcome to Echo Live. My name is Anna, coming to you from the Michigan Science Center's Echo Distance Learning Program. Today we are talking all about luminescence, which is a really cool word. We are going to talk all about different sorts of things that luminesce and different types of luminescence, because there are actually quite a few. Now, I can already see some friends starting to chime in on the chat feature of our various programs. Hi, Evan. Hello, Kian. Hi, everyone who's introducing themselves in the chat. If you haven't done so already, go ahead. Tell us where you're watching from. You can tell us what grade you're in. Tell us something fun about yourself. Practice using that chat feature, because it is your best way to communicate with me all throughout our program about luminescence today. You can answer my questions. You can ask your own questions. And of course, we can make suggestions for sorts of experiments we might want to try together. So we are talking about luminescence. So once you've gone ahead and introduced yourself in the chat, my next question that you can tell me using that chat or that comments feature is, can you name me something that is luminescent? Or if you're not quite sure of an example of luminescence, what are we talking about when we're talking about things that are luminescent? If you're not quite sure just yet, that's okay, but I'd love to see what you guys think. I'd love to see what your background knowledge is, because that's a really important part of the scientific process, is bringing in all of your background knowledge. And we've certainly talked about some big words that are going to have to do with luminescence here on Echo Live in the past. Hi, everyone tuning in. Lots of new faces chiming in too. Lots of familiar faces. Hi, Natalie in 3rd grade. How cool of you to join us here. Now, I gave you a little bit of a hint behind me. So behind me on my screen is an example of something that is luminescent. Do you know what these are called? These are really amazing. And I've never actually gotten a chance to see them in real life, but you guys got it. These are the northern lights, and the northern lights are actually luminescent. So we are talking about things that glow here on Echo Live today. Now, let's see, you've named me some other examples of things that are luminescent. Someone's named fireflies. Fireflies are an amazing example of luminescence. That's actually one of the main things we'll talk about today. Yeah, the northern lights, lots of people chiming in. Now, oh, someone said light bulbs. Some light bulbs are luminescent, but others are not. And we'll talk about the difference between those here on Echo Live today too. So I'm so glad to see that you guys have lots of background knowledge about luminescence. But we can basically break luminescence into 3 categories. But luminescence is what we call a cold light. So what do I mean by a cold light? Obviously, I mean it's not hot, right? So we might be familiar with fluorescent and incandescent light bulbs. That's something that we've definitely talked about here on Echo Live in a previous episode. Now, incandescent bulbs, right? We said that those kind of bulbs, we usually heat up a filament, a really, really thin piece of metal, so hot that it starts to glow and emit light. But that is not luminescence. That's incandescence. Luminescence happens without heat. So it is something that emits light without also emitting heat. And so that's what we're going to keep in mind as we move throughout our program today. The first thing we are going to talk about is fluorescence. So I'm so glad you guys recognize that some light bulbs are luminescent because they are fluorescent bulbs. Now, we don't use heat in order to light up fluorescent bulbs. We use energy. We use electricity, right? So we can take something like a lamp here, and we can turn it on. This is a very fancy kind of light bulb, but we are sending electricity into this light bulb, which is exciting the gases inside to a higher state. And then when they fall back down to their original ground state, they re-emit light as a product of that process. Now we're going to look at some photos, and we're also going to look at some diagrams that I have about these different types of luminescence. And they may seem a little complicated, but we're going to go through them together. And it's important that we figure out the differences between our different types of luminescence. We said the first one we're talking about is fluorescence, like our fluorescent light bulbs, but all sorts of other things are fluorescent as well. The easiest way to tell if something is fluorescent is that it immediately takes the energy that we've put into the system, either from shining a black light on something or by sending electricity through that object. It will then immediately re-emit some light energy. Now, as a general rule, we say that, of course, we can't emit light that is of a higher energy than what we started with, right? That energy has to come from somewhere, and we lose just a little bit of it in that emission process. So this would be the ground state. This is where we started from. These arrows, these light blue arrows, represent the excitation process. So either by energizing it with electricity, or like in these images, if you shine a black light on fluorescent molecules, a little bit of that energy gets lost in the emission process. And then this is what we see as visible light, as these fluorescent dyes sometimes. Now, these are actually cells that have been dyed with fluorescent dye. It helps scientists to identify all sorts of structures of cells that are too small for us to see, maybe with our naked eye. And so they'll actually design dyes and they'll tag them with different fluorescent dyes that will attach to different parts of a cell. So you can see in the case of this one over here in part C, that the nucleus is dyed with a violet dye, whereas the rest of the cell absorbs this red dye. And so we can actually distinguish between the different parts of cells by using these fluorescent dyes. But we experience fluorescent stuff all the time. If you've ever been to a blacklight party or maybe somewhere where they've had black lights going around, you might notice that all sorts of crazy things glow under the black light. We've had a whole episode about blacklight science, right? We said that in a lot of laundry detergents, we actually add fluorescent molecules so that they're actually able, like my lab coat, to give off this nice bright white kind of shine under UV light, even the UV light that comes from the sun. Now, I also have on this bracelet. You might notice that I wear this bracelet all the time, and it's actually a science bracelet. I actually made it at the Science Center. And the reason it's really cool is because these are also fluorescent. You can see that under the UV light, they will immediately take the energy from the UV light and re-emit it back to our eyes differently. So it looks much different outside of our UV light than it does under the UV light. But other things in our homes or around us are fluorescent as well. Remember that this process is immediate. So you'll notice that as soon as I take away my bracelet, right, they go right back to looking normal. They only fluoresce while they're directly underneath the UV light, while they are absorbing and immediately re-emitting that energy as light that we can see from our eyes. But highlighters are also fluorescent, certain ones at least. So if we take something like our highlighter here and I hold it under the black light, not only is the plastic casing fluorescent, you can see that it certainly emits a different wavelength of visible light back to our eyes than we started with, but the ink is as well. So not that I recommend drawing on yourself. Definitely, if you're going to try this, make sure you get your parents' permission, or you can always write on a piece of paper. But I think it shows up really well right here on the skin. So even if I take my hand out from under the UV light and I draw something on my hand, it might be really difficult to see right now. Maybe just in the right light, you might even be able to see it. But when I hold this fluorescent dye under the UV light, it changes the wavelength of light that carries to our eyes completely, right? So this is fluorescence. And like we said, the thing to remember is that when we remove the source of energy, like our light, that fluorescence goes away. It has to have that constant source of energy so that it's constantly going up in electron state and back down. Up and back down. Once you remove the energy, things will stop to fluoresce, which is okay, right? Because we don't want our fluorescent light bulbs to be on all the time. So fluorescence is really good. We can use it for lots of things. And we're going to come back to fluorescence in just a little bit. But there's another kind of luminescence that I think is even more amazing. This one we call phosphorescence. Now, phosphorescence has a lot to do with things that glow in the dark. So when I was younger, I used to have all sorts of these different star stickers stuck up to my ceiling in my bedroom. These are what we call phosphorescence, right? Because we know that when the lights are on, those glow in the dark objects, they get charged up with energy. They absorb that energy from the ground state. But when we turn off the lights, they continue to glow. So there's a big difference between fluorescence and phosphorescence. So we have both diagrams here, right? We said that in fluorescence, we absorb and immediately re-emit that energy that was given to that object. But in phosphorescence, we have this weird kind of interesting middle state that we call the metastable level, or my favorite is to call it the electron trap. Once phosphorescent materials like your glow-in-the-dark stickers absorb energy, those objects kind of get trapped in this middle zone where they are going to continue to glow visible light until an outside event either causes that object to go back up in energy or back down. So it can't really leave this state, or it really doesn't want to, which is why some glow-in-the-dark or phosphorescent objects can actually glow for days after they've been charged up. It's just all about the efficiency of those phosphorescent molecules. So things that glow in the dark after you remove your source of energy, we call that phosphorescence. And I brought kind of a fun demonstration for us to try. We are going to make some glow-in-the-dark phosphorescent slime. So you can either make fluorescent slime or phosphorescent slime following really similar procedures. We'll start with doing our phosphorescent slime. So for that, I actually bought glow-in-the-dark glue. So they sell this at craft stores. You can get it really probably anywhere that sells or has a crafting section. We are going to make phosphorescent slime, right? That means that it's going to glow even after we remove our source of light. Now, they make this really similarly to how you'd make any other sort of glue slime, because this was already designed with those phosphorescent molecules in it. All you have to do, right, is pour the amount of glue down into your bowl that you'd like to turn into slime. We talked about slime making on a past episode of Echo Live, and we know that slime has a shelf life. It doesn't necessarily last forever. If you treat your slime really, really well, if you make sure that you keep it somewhere where it's not getting dried out, so in a closed container, and you keep it off of the floor and off of your carpet, right? I've had slime last me months, but that's not always the case. Sometimes it depends on the type of glue you buy or the type of supplies that you use. So maybe if you do buy a bottle like this, what I like to do is only use a little bit at a time. Make just enough for me to have slime to play with, and then keep some in the bottle that I can use later, because this is airtight and it's not going to dry out. Now, the glue acts as our polymer base for this activity, right? Glue is a polymer. There's all sorts of cross-linked molecules here inside our glue, but right now we say that it is in a state of being a liquid. If I were to reach my hand down here into this glow-in-the-dark glue, not going to be so fun to play with, right? It's definitely going to be sticky. That's what glue is designed to do. So we need to add a couple more things if we want to turn this into slime that's actually fun to play with. So the first thing we always add is some water, right? Because water is what's going to turn it more into slime and less of a kind of hard, rigid solid like a bouncy ball. So you want to add an arbitrary amount of water, definitely not more than half and half, but I like to just mix it until it's at a consistency that I want to play with. So I add water until the slime seems like it would be fun to play with. But again, we're not touching it with our hands until we've turned this into slime. Otherwise, you might have kind of a bad time, because right now adding water didn't do anything to change our state of matter, right? This is still a liquid. I could still pour it out of this container, get it all over the table, make my hands nice and sticky. So that is certainly not what you want. I want mine to be just a little bit more watery than that. So we'll add just a little bit more water and mix. Remember, at this step, right, we can always add more glue or more water, but you can't take any away. And so that's why we want to do this step before we add anything else to our reaction. Steve said that he made slime one time and it was so sticky that he had to wash his hands like 10 times. Well, I've got some tips that we'll go through on how to make sure your slime turns to a good consistency that's not sticky as we go through this experiment. All right, so now that my glue and water mixture, what we might call a solution, right, is nice and homogeneous, it's evenly mixed, and it's at a good consistency. It's really, if this was slime, it would be nice and stretchy, not too firm. So now we're ready to add our last few ingredients here. Baking soda is going to help to stabilize the bonds in our slime that we've created. And you really only need a tiny bit. If you were cooking, I might call it a pinch. If you're more interested in a scientific measurement, I would say that you need about 1/4 teaspoon for the amount of glue that I put in my bowl down here. So about 1/4 teaspoon of baking soda. That's going to help to stabilize the bonds that we create and really just mix that in really, really well. Now, that didn't do anything to change the state of matter still, right? If we want to change this liquid into slime, which we call a non-Newtonian fluid, you guys have it, we need some sort of activator. We need an activator, and that could either be a supersaturated borax solution or contact solution that has sodium borate in it. Now, you might notice that those two words sound kind of similar. So borax or borate, they both have the same active ingredient in them, which is what is going to cross-link the molecules in our glue and turn them to slime. Now, same thing goes when we're adding the contact solution as when we were adding water. You can always add more, but you can't take it away. So there's really no exact ratio of this. Some people said that they have slime that always gets hard. If you have slime that always gets hard and you've been using borax, I might recommend trying contact solution. This stuff does get you a little bit of smoother slime than you might get from using borax. I think because it just mixes in a little bit more evenly than the borax does. But if your slime gets hard using the contact solution, that means that you're using too much. It means that you have put so much in here that those molecules have really locked onto each other and they don't have as much freedom to move as you might like with slime. So we're gonna go ahead now, just pour just 1 squirt onto the top and we'll begin to stir. And already our slime is starting to turn slimy. Still not quite at the point where I would want to reach my hand in there and play with it. Altogether, this should take you about 2 tablespoons of slime or of contact solution for about the amount of glue that I poured into this cup, which is maybe 1/3 to 1/2 a cup of glue that I started with. Now, it's really starting to turn slimy, and this is the point where I would recommend using your hands to mix. It is going to be sticky at first, so it's definitely going to be sticky at first, but the only way to really make sure you're getting those borate ions in between all of your glue molecules is by kneading your mixture, is by really squishing it in and messing around with it. So let's go ahead and just start mixing our solution here. And it's a little sticky, but it's actually not as bad as I thought it was going to be. So we're just really kneading our mixture. You could also put a little bit of contact solution or borax onto your hand, which can help you to kind of get it to unstick from you. Really pushing it back and forth, turning it into slime. And this works 100% of the time. So it really is just about being patient, really getting it to mix together. You'll notice that now it's wanting to stick to itself more than my hands. I usually clean this hand right off, pour a little bit down in the bottom of our bowl, and continue kneading. The more of that borate you add, right, the more the slime is wanting to cross-link those molecules and really turn it into what we call a non-Newtonian fluid. And some of you might be thinking to yourself, I make slime all the time. I understand the point of slime and how you make it, right? But what's cool about this slime is that it really ties to our episode about luminescence. So notice the color of our slime right now as I kind of just get it off my fingers. It's definitely this really pretty bright blue color. But we want to charge up this slime with our UV light bulb here. So we'll go ahead and let's go put it underneath our UV light. And it definitely fluoresces just a little bit. You'll notice that the color of the slime when we're looking at it under the black light is certainly a little bit brighter, maybe a little bit more fun than the color we were initially seeing right out of the bottle, right? Especially if I bring it over here. We'll notice there's a big difference between this color and the color we're seeing off our slime. But we said that this stuff is phosphorescent, not just fluorescent, right? Meaning that if I take it away from our black light after we get it nice and charged up, really exciting those electrons to a higher state, even when I turn off my light, it is still glowing, right? It's still brighter than the glue in our bottle. The longer we leave this to charge underneath that UV light, right, the more energy gets stored up in these phosphorescent molecules. And so this is really just a simple activity, something that you can carry around with you to demonstrate phosphorescence. And you can even play with this slime after dark because it is phosphorescent, right? You'll be able to see it. But of course, with any slime, if you want it to last, you have to make sure that you always keep it in a closed container when you're not using it. When I say closed, I mean airtight, so that it's not going to let air molecules in and start to evaporate the moisture out of it. But also we want to keep it off of the floor so that it doesn't pick up any sort of dirt or grime or pet hair. Because if you live where I live, cat hair is just about on every single surface besides my kitchen table. So phosphorescent slime. There you go. Now, we have a few more activities. If you're interested in making fluorescent slime, we might not go through that activity here today, but all you can do to make fluorescent slime, if you don't have the materials for this, I'm sure that you have a highlighter laying around your house. You can make fluorescent slime by just popping the end off of your highlighters. You obviously won't be able to use this as a highlighter anymore after you turn it to slime. But if you just pop the end off of your highlighters with parental supervision, because I had to use a pretty sharp pair of scissors, but you could probably use tweezers as well. If you take the dye pack out of it, you can soak this in water to use as your water mixture into your clear or white colored school glue. So you can actually turn this into fluorescent slime. So again, this one glows under the black light, but once you remove that source of energy, it no longer glows. So it's kind of different from our phosphorescent slime, but still really cool. And this might be a little bit easier to come by than having to go out and purchase that glow in the dark glue. But either one, they're both very cool and they are both luminescent. So we've talked about fluorescence and phosphorescence, but there is one more major category of luminescence that we call chemiluminescent, meaning that we don't have to actually give any sort of light energy in order for it to re-emit light back to us. In chemiluminescence, that change in energy comes from a chemical reaction. So let's take a look at a pretty amazing photo. In this picture, we have chemiluminescent living organisms. You might have heard of someone call this bioluminescence, and that is still completely correct. Bioluminescence is a part of chemiluminescence because organisms that are able to glow like this, even without the input of energy from the sun or from another energy source, they actually go through chemical reactions inside that organism's body and emit light back to us. Of course, this comes with the diagram, right? So if we're thinking about our past diagrams, right? Well, let's go back one more slide. We had fluorescence where we had an absorption of energy, an immediate emission of energy. In phosphorescence, we had an increase in energy that gets trapped in this electron state until it's able to fall back down because of an outside event. But in both of these cases, we had to supply light for the energy for this reaction. In chemiluminescence, this change in state comes from a chemical reaction. So this doesn't just happen in nature. I changed my background here to some fireflies because those living organisms that we just saw on that beach, that is an example of chemiluminescence, but so are fireflies. They go through a chemical change inside their own bodies as well that glow. So their name is a little bit deceiving. I know we call them fireflies, right? But they're not hot. It's not an incandescent reaction that produces the light. It is a chemiluminescent reaction that gives us that light from fireflies, which is pretty cool. But another example of chemiluminescence happens right in one of our favorite chemistry toys that you can get at just about any store, even the dollar store, happens in glow sticks. So I'm sure we've all seen a glow stick before, probably used ones that we've gotten at the store, at a party, maybe at a festival or a fireworks display. I know that they're pretty cool and easy to come by. Now they are fluorescent. You'll notice that if I hold them up underneath my light here, that they do fluoresce. So they do emit energy back towards us when I hold them up underneath the UV light. If I take it away, right, we can tell this color is largely the same, but they're definitely much brighter here underneath our UV light. But we're more interested in the chemical reaction that happens inside. Now, we've all taken a glow stick before, I'm sure, and we have cracked it to make it glow. But I want us to take a look at what's actually going on inside the glow stick that gives us that chemiluminescence. So if we take a glow stick, let me zoom in. If we take a glow stick, right, we always take it and we just crack, and it immediately starts to glow. Now, if you've used one of these before, right, you know that the more you shake it, the more it glows from top to bottom, and that process happens very quickly. So we have a chemiluminescent reaction, but we said we want to look at how that actually works, right? Why does cracking a glow stick make it start to glow? How does that make any sense? Well, it's because inside this tube of the glow stick, the outer plastic layer, there is another tiny glass tube inside that glow stick. So I have one that I've deconstructed before our program. So if I take it and I zoom in so you can see maybe even just a little bit better, you can see that I cut the top off of this one and I can actually pull out another vial. So this glass vial is full of hydrogen peroxide. When you crack the glow stick, you actually break this glass, which releases the peroxide into the liquid that fills this tube. When those two molecules mix together, they undergo a chemiluminescent reaction, which produces light as those two substances mix together, which is pretty amazing, right? It's a pretty amazing reaction. And I'm sure we've all been told before, right, that we need to be careful around glow sticks because glow sticks are relatively safe. We give them to kids all the time. They are really cool science toys, but we need to use them appropriately because they can be a little bit dangerous, right? We said that they are filled with two chemicals. If you do ever accidentally break a glow stick and it gets on your skin or in your eyes or in your mouth, you should definitely rinse it with water for at least 15 to 20 minutes. Make sure you get all of those chemicals out of your eyes, your mouth, and off of your skin because they can be irritating. But really the most dangerous thing about a glow stick is the glass inside. So that's why I'm sure we've all been told you never chew on a glow stick. You never want to really mash it up because if you were to puncture this hard plastic shell, you could get little tiny shards of glass under your skin or in your mouth, anywhere like that. And so we do need to make sure we're using glow sticks appropriately and carefully. But like we said, they are very cool chemistry toys. So let's go ahead and set that off to the side. But glow sticks are not the only sort of chemiluminescent reaction that scientists are concerned with. Actually, the reason that glow sticks were invented is in the 1960s, scientists looked at fireflies and they thought, this is amazing. Why can't we do that? Why can't humans reproduce this in a lab? And so nature was actually the inspiration for this chemical process. So they looked at fireflies, they figured out what ingredients they might need, and they actually created this mixture or combination of only two chemicals, which makes our glow sticks glow. But we can get those separately, right? So these two things aren't just used in glow sticks. They have other purposes as well. Now, if you are a true crime fan like I am, maybe no one just yet, but we know that there is this substance called luminol that we spray at crime scenes. And luminol is also chemiluminescent. It is getting its energy from a chemical reaction that takes place when two substances mix with each other. One of those substances is luminol, and most often at crime scenes, we are using luminol to check for the presence of blood. But I want to show you exactly what luminol does and how it works so we can kind of understand why it's an important scientific tool, but that it doesn't necessarily note that something is blood on its own. So I have some luminol solutions here, and don't worry, I have no blood. We're not going to test any blood here because it's actually not necessary. Luminol is kind of a fine yellow powder. It doesn't very easily dissolve in water, so you have to really, really stir it up. But let's go ahead and let's add some luminol here to our first beaker. Just about 50 milliliters of our luminol. Let me zoom in so you guys can have a closer look. And I want you to pay close attention. Let me maybe scoot stuff off to the side so we're not distracted. I want you to pay close attention when I mix this substance into our luminol solution. Ready? Maybe I'll zoom in just a little more. Oh, wrong way. There we go. All right, pay close attention to the substance at the bottom of the glass. Oh no. Not interested in working for me right now. Very interesting, actually. Let's try our next one. And if this doesn't work, I'm just going to dissolve some fresh luminol because this has been sitting out for about an hour, which may have been beyond the shelf life of the luminol solution. We said it doesn't really easily dissolve in the water, so you really have to stir it up. You can see it down there at the bottom of the glass. So basically, we have a super saturated solution. It does not like to dissolve. But let's try our next solution, and let's see if this one works. All right, so I've got another solution to add into our luminol. We're taking a close look at this beaker this time. Let me maybe even scoot the other one out of the way. There we go. Did you guys see that bright flash of light? Now, luminol, unlike phosphorescence, doesn't normally experience a sustained glow. Let's try that one again. And I'll tell you this time what I'm adding. So I have the luminol solution. Add in about our next 50 milliliters. And what I'm adding is a solution of bleach, which is really important for us to note when we're using this in crime scenes, right? Because normally crime scene analysts will spray a whole crime scene area or a police scene with luminol looking for something to glow because that could denote that something is blood. But you'll notice that other things glow when they react with luminol as well. And so if we take our bleach and we're going to mix in just about a 50% mixture, let's zoom back in. Don't want to miss this because it happens instantaneously. It only happens for a brief moment, but it glows very, very brightly. So even though luminol might help crime scene analysts to find specks of what might be blood at a crime scene, it's not enough on its own to tell you that something is blood. You do have to do additional tests. It's kind of a misconception about luminol. Just because something glows doesn't mean it's blood. It could be all sorts of things like bleach, or my other solution was hydrogen peroxide. And I'm curious as to why it didn't glow when it did in practice, but anything that is oxidizing, anything that is able to react with our luminol solution will glow instantaneously when it reacts with luminol, which makes it a very important science tool. But again, not on its own can it tell you that something is necessarily blood, because in chemistry, all sorts of things have very similar properties. All right, now I'd like to pause and find out if you have any questions about the activities that we've done so far. You notice my black light or my phosphorescent slime is actually glowing so bright that it's turned such a bright green that it's interfering with my green screen. That's just how charged up it's gotten under the light in the last few minutes here. It's glowing really, really brightly, and now it is what we would consider to be phosphorescent. So if you have questions about any of the activities we've done or the types of luminescence we've discussed so far, type those in the chat. I would love to answer some before we go. But I'd also like to let you guys know about a very important announcement. We are offering a prize in exchange for your feedback on our Echo Live programs. We have been so excited to provide Echo Live for such a long time now, ever since the middle of March when we launched our episodes. This is episode 62, I believe, which is amazing. But we'd really like to know what you all think about Echo Live. We want to know what has been your favorite experiment so far. We want to know what things you'd like us to try on Echo Live next. And if for filling out our survey, you are also able to enter to win a free week of My Size Spark Camp, which are our virtual camp options. I will be there. And so you will spend part of your day with some of our online virtual summer camp counselors. They're going to show you some cool hands-on activities. We'll actually get to interact with you even more on camera and through the chat feature. But of course, you'll get to meet me here on Echo Live sometimes as well. We'll get to do private shows just for our campers. So it's really an amazing opportunity. If you have been enjoying Echo Live so far, I highly recommend signing up for My Size Spark Camp. There's more information about these on our website. And of course, we'll be posting a link to that feedback survey with the description to this video so that you can give us your thoughts, tell us what you think, and enter to win a free week of virtual camp, which will be really, really cool to see some familiar faces there. So Leslie asked, how does the light source make an impact on the flow factor? And it's all about energy provided, right? So if we think back to really any of those diagrams, maybe not our chemiluminescent one, but if we think back to our fluorescence or phosphorescence, Absorption is arbitrary. It just means that there's been an increase in excitement level for that electron. And so really, whatever source of light you use provides the energy. Some wavelengths of light provide more energy than others. Some provide less. Like we said, it doesn't necessarily have to come from light. Other things can give electrons energy as well. Anything that acts on our electromagnetic spectrum can have an effect on these processes. Good question. The answer is really just, it depends. No questions just yet. If you're looking for activity guides for our slime recipes, go ahead and find our All Slime All the Time recipe. It's on the Michigan Science Center's website under at-home science activities. Just remember, you're going to sub out your regular glue for one of these cool packs of glow-in-the-dark glue that I got at the craft store. Super easy. You can also use the highlighter method. And again, you just soak your highlighter dye in water and use that as the water you add into your slime mixture as well. So really easy processes, growing on things we've already learned on past episodes of Echo Live. If you've not watched the slime making masterclass, I highly recommend it. Or you can find those activity guides online. Let's see. No questions. Otherwise, I will see you all next time. We'll be back here tomorrow at 2:30 with even more Echo Live. See you later.